Okay. How about now? Ready? Okay, I think I'm live. I think you guys can hear me. Just in the chat, if you could let me know. My first time. Okay. Yes, awesome. Okay, so sorry for wasting all the time. I will get right into it. So my name is Jordan Last. Oh, hold on. Okay. So yeah, my name is Jordan Last. I'm the founder of DFINITY Labs. I've been following the internet computer for quite a long time, since 2017. Uh, I love open source. I love permissionless. Love web technologies. Pretty proficient at the HTML, CSS, TypeScript, front end, back end stuff. I've been working really hard to bring TypeScript, GraphQL, and future other Web2 technologies to the internet computer. And as part of the vision of DFINITY Labs, which is to really accelerate the adoption of Web3 and of the internet computer in particular, to help achieve that vision, we are going to produce a ton of content. We really want to make a bunch of courses. My second teammate will be joining me just a couple weeks from now, so we'll get him on doing lessons and courses and stuff as well. And this course is really designed to be for complete beginners. I just want to get it all out. You're completely new, web development, front end or back end. I want to start from the ground, work our way up, show you everything you need to do, hopefully help you through uh, all your problems. Obviously, because it is kind of a live stream video environment, it will be difficult. I do encourage you to reach out to me or others, Telegram or Twitter. My handle is lastmjs. Send me a DM. Go to the forums, forum.dfinity.org for internet computer specific stuff. TypeScript and JavaScript, HTML and CSS. I mean, there are so many resources out there in addition to this resource that I'm. Hopefully, with all that, we have. Hopefully, you won't get stuck. Also, the audience that I'm aiming to educate here, you're going to be completely new to development in general. I'm also kind of targeting this at Web 2, as we call them, Web 3 space. But if you're just I guess we could say a regular web developer, if you have been developing for the web, internet-based web applications for the last even decades, I really hope this material helps you as well. I really want to explain what Web3 is, why we call it Web3, major differences. A lot of Web2 people have a big problem with Web3. They hate the degenerative behavior. They hate the speculation. I don't know, they seem to hate so many of the applications built on Web3 and blockchain. And because of their hatred, or maybe because of the putridity of many things built with Web3 and blockchain, they miss the amazing, powerful technologies that underlie our space. I really am a firm believer that centralization, generally speaking, is a very good thing, especially in the technology space. So that's just a little bit of an intro. We're going to dive right in here. Let's just go over the history of web development and see how we got here. So Web 1.0, you can think of that as basically HTML and the web browsers. Back in the very late 80s, I believe, is when Tim Berners-Lee came up with the idea of some kind of language that could link documents together. a few years later, Mark Andreessen and his crew built the first web browser called Mosaic. And they were able to have text and images and assume eventually videos and stuff. And they actually were able to create the first mainstream application of this vision that Tim Berners-Lee had, which was, I'm sure he could explain it better, obviously, but to create this rich ecosystem of documents that could link to each other. And it took off like wildfire. I think they had many hundreds of thousands or millions of users relatively quickly. Mosaic didn't work out entirely. Netscape was its successor, which Mark Andreessen also had a huge part in. And during the mid to late 90s, Microsoft came in as well. And the web really took off. The browsers started being deployed probably on most home computers. That's when people started getting computers in their home. That's when the internet really started taking off. And that was all Web 1, which basically, if we could simplify it, it'd be the static web. Basically, you have a document on some server. A server, by the way, is just a computer, or even more simply, a process or a program running on a computer. And that computer's whole purpose is to serve content. You open up your web browser, you type in google.com, there's going to be some computer, some program somewhere that's going to receive that request, return specific information, bytes that are needed to render that web page in your browser for you. Web 1 is really marked by being static. What do we mean by static? Just imagine just text, maybe images. Right? There's not much interactivity. Just think of a book compared to television. Not television. A book compared to a computer program, right? The book just has static text and information. It doesn't really change. Whereas on a computer, you might have text, but you can scroll around, you can enter text box, do all kinds of stuff. And the web was static for a long time. Like the programming model wasn't very advanced. It was very difficult to do anything but create static experiences. But something that Web 1 maybe did really well was it was relatively more decentralized. I was a kid at the time, so I didn't personally run any servers from my home, but I think from what I've heard, a lot more people were interested in running their own servers from their homes and providing their own content to people through those servers. So Web 1 was static, but relatively decentralized compared to what we have today. So Web 1 leads us into Web 2. Obviously, being completely static is not ideal. It'd be nice if you could interact, if you could enter your information in, if you could have email, if you could even do e-commerce, put credit card information in, all the crazy stuff that we do, note-taking apps, all that craziness. That's what Web 2 really enabled. And, Web 2, you could think of it, well, like I said, it's dynamic, but what allowed this to happen was the ability, I would basically say JavaScript combined with HTTP requests from some people call that AJAX. I think it's an extremely confusing term. It just means asynchronous JavaScript XML HTTP request. It was the very specific API that the browser lets you use to do HTTP requests from the browser, from JavaScript, which allowed JavaScript, which was a general purpose scripting language, allowed JavaScript to actually send arbitrary internet requests to other computers, other servers around the world. And with JavaScript, HTML, CSS, and the ability to perform requests, we were able to create extremely rich applications, which led to the Web 2 boom, right? Like, we've been in this boom for like 20 years now. Everything that we're using, or a lot of what we're using every day on our computers, on our phones, are rich like web applications. And it's possible because of web technologies. Something happened. in the transition from Web 1 to Web 2, we lost something beautiful. And really, we lost visualization. The specific internet requests that most developers were using, called HTTP requests, these requests are limited in functionality. They are what we call stateless. They do not allow you to store information or compute using the internet itself. And what's beautiful about the internet, and there is a distinction between the internet and the web, by the way. The internet is a set of protocols that allow communication between two programs or two processes, basically anywhere in the world, as long as there is a connection. And the internet is extremely decentralized. Like, yeah, there's a few major ISPs depending where you are, but generally speaking, or if you think more a broader view, there are probably hundreds or thousands of ISPs in the world that compete, bring internet service, and that's beautiful. And because the internet protocols are open and they are permissionless, and because there's so many ISPs, that provided a beautiful, stable foundation for companies to come in and build on top of those protocols. And now every single business basically in the world runs on top of the internet protocols. But all they do is communication of data. You can send data from one process or one computer to another. There are two major things that they're missing. One is the ability to store data or information. The internet does not have a database built into it. The other is the ability to compute on information. The internet does not have computational capability, generally speaking. The internet just sends data from one point to another. And Web 2, to create all the amazing applications that we have today, you needed computation and you needed storage. And the problem is the internet protocols did not provide that. So companies had to come in, build on top of the internet protocols, and provide these computation and storage protocols for us. Except they didn't do it generally in a way that is open, permissionless, and decentralized. They did it in a proprietary, walled garden way. For example, Google, for example, Amazon, they created huge clouds that everybody uses, not everybody obviously, but a large portion of web companies use, because they provide the missing storage capabilities, they provide those, and the missing computational capabilities, they provide those. They give you access to millions of computers, all kinds of different database technologies, and all you have to do is sign up with them, follow their rules, and pay them, and then you can build your stuff. And make sure also that you don't offend them in any way. Make sure your religion or your politics don't conflict with them. Otherwise, they might deem you a threat to the public peace and shut you down. Now, I don't want to get into politics or religious views or anything like that, but we can all agree that when you centralize power, you centralize the ability to censor. And over time, if you listen or learn about history, right, centralized power leads to many, many, many horrible problems. I've listened to some horrific things that have happened past recently, and I don't want us to ever go back any of those things. So part of my goal, at least years, is to help us continue to decentralize and tear down power where it exists. And one place is these Web 2 companies, right? The Amazons, the Googles, the Microsofts. In my opinion, they have far too much power, and we now have the ability to kind of tear that down. Now, if you're not into that, if you're okay with the Web 2 companies and the walled gardens, that's fine. There's another reason why you might be interested in what we're discussing. And that reason is security and security, scalability. We'll go over them. There are many properties that decentralization brings. One is decentralizing power, so censorship resistance. platform risk. If they don't agree with you, they could deplatform you. Another, I guess, security, you could wrap it up in security. A lot of applications you might build on Google's cloud or Amazon's cloud, they aren't necessarily built to work in adversarial environment. So blockchain is built to be Byzantine fault tolerant. Or in other words, to work in an environment where computers might be faulty, either because they're run by malicious people or because the computers are just faulty, which we live in, we're mortals. The world is not perfect. And so our things break. And a lot of, if I spin up an EC2 instance on AWS, that's a single point of failure. It could go down for many reasons. And we see that big tech, big clouds definitely do go down in many cases. So for all those reasons, and probably more, a decentralized cloud experience is possibly beneficial. And we'll be discussing that. And we'll actually be learning how to build applications for a decentralized cloud instead of a centralized. So this leads us into Web3. I mean, we've been talking about it, but Web2 centralized computation and storage. As I see it, Web3 decentralizes computation. Instead of a handful of companies providing you their service, we now have permissionless, open, incredibly neutral, you could say, protocols that allows computation and allows storage with databases. And in particular, we are going to focus on the internet computer. Disclosure, my company Dimension Labs is funded by DFINITY, which is the foundation that created the internet computer. But disclaimer, I've been interested in the internet computer far before I started Emergent Labs, far before I ever got a grant for my other project, Pseudograph. And in my opinion, it has like the best vision in Web3, or one of the best. And that is really to be a decentralized cloud. In my opinion, that's the easiest way to describe it to people. It's a decentralized cloud. Would you rather have Google control your cloud, or would you rather own the cloud along with many other independent entities? And that's the distinction here. Web3 lets us build on open, credibly neutral protocol. That's amazing. And you can build interesting applications that are not possible on Web2 with Web3. One application that you cannot build on Web2 is something called Bitcoin. Bitcoin is a cryptocurrency. You simply cannot build a cryptocurrency on Web2. Many people tried to, it just didn't work. You can't build it if somebody owns it and can shut it down. Bitcoin is massively decentralized. Thus, it has these emergent properties, these properties that don't exist in small networks. As Bitcoin's network grew, this property emerged. Multiple properties emerged that allowed it to be a credibly neutral store of value. And that's fantastic and amazing. Other applications you can build are general purpose computers like Ethereum. And Ethereum unlocks a whole ton of applications, right? But Bitcoin and Ethereum are both extremely limited in their throughput, their scalability, their capacity, their efficiency as well. That's why we need something more like the internet computer, or like other competitors, Ethereum, or projects similar to Ethereum. We need a scalable, decentralized. Hearing that the video might be frozen. I'll go this. I don't know if I gave this disclaimer, but is my first time streaming, so my setup might be really suboptimal. It will get better over time. Can you guys still hear me? Great. Okay, well, if you can hear me, sorry about the video. Okay, so I'll just keep going. I'll try to figure this. So, okay, we talked about Web 2, or Web 1, Web 2, and Web 3. Hopefully that all makes sense. If you're not convinced, I encourage you to go read the Bitcoin white paper. Try to look for the underlying principles and why this could not exist on centralized cloud platforms. Read the Ethereum white paper and I think the same thing. And just consider all the crazy hacks that we have and consider the root cause. Why do we have these hacks? And I think building something for a Byzantine fault tolerant environment, an adversarial network where you assume computers can break and faulty, building something from the ground up with those assumptions really is what gives Web3 power. So there you go. So that's just a little bit of an introduction. Now we're going to do kind of an overview of the different technologies that you're going to need if you're going to build a full stack application on Web3. First, we'll start by talking about the two major environments that you'll be developing in. All right, so two major environments here. One is the web browser. The web browser is where your front end code runs, right? That is the user facing part of your application. People call that the UI, the user interface, or the GUI, the graphical user interface. You don't have to use a web browser if you don't want to. Like, you could develop desktop applications, you could develop mobile applications, Android or iOS. This is a Web3 course, full stack. So I'm going to focus on the web aspect. What's cool is you can actually build desktop applications that are basically web applications, and you can build mobile applications that are basically web applications as well. So it is an extremely versatile set of skills to be able to develop a front end on for the web. So I highly suggest you master the skills and the technologies that will let you develop for the web. So that's one environment that you have, is the web environment. And then there's another environment, which is your backend environment. That's generally the server. And traditionally speaking, for a full stack web developer, you're going to probably use Node.js. You can use other languages and there's frameworks and things, but Node.js, if you want to be like a JavaScript full stack developer, it kind of makes sense to use Node.js because you can use the same technologies on the front end as you use on the back end. And so you've got this Node environment, which is basically a JavaScript engine combined with libraries or APIs that give you access to things on a normal computer. So for example, it gives you access to HTTP requests. It gives you access to the file system. It gives you access to other networking, anything that you don't have access to in the library, in the web environment, that Node environment is going to give you different APIs. So most important thing to understand here is that the web browser environment and the backend or the Node.js environment, they both might use the same language, JavaScript or TypeScript, but they're going to have different APIs available. And this will become very apparent to you as you try to use something not be supported in Node, but is supported on the web, or vice versa. And it'd be nice if all the APIs were the same, but I think fundamentally speaking, there needs to be a difference because, at least for now, eventually we might have the browser fully integrate with the desktop server. That's a discussion. So you got these two environments. That's the traditional way of doing it, is to have Node.js. But the way that we are going to do it is we are going to use Internet Computer. And the Internet Computer is a backend environment. And traditionally, on the Internet Computer, there have been two languages available. One is called Rust. Rust is an excellent language, but it's a very difficult language to learn. It is a systems language or a low-level language. And if you're just getting started, you definitely don't want to start with Rust. Once you get a little bit more advanced, you can use Rust if you want, but it is still going to be more cumbersome to use than something like TypeScript or JavaScript. Another language available on the Internet Computer is Motoko, and that is a language that the DFINITY Foundation created specifically for the Internet Computer. In my opinion, I don't like languages that are domain specific, is what we call them. If those languages are very, very similar to other languages that already exist. And in my opinion, Motoko is similar enough to something like JavaScript or TypeScript that I think it's debatable whether or not it should have been created. Learning a new language is a very difficult thing to do, and you cannot use Motoko generally to do the front end. So, and Motoko is new, doesn't have that many libraries written for it, doesn't have a huge open source registry like NPM. So I heard it, just the developer tools are immature. So you're going to run into those types of issues with Motoko, but it is supported by the DFINITY team. That's something you can rely on, is that you know that they're going to be working on it. I'm just going to turn the video to black for now. Yeah, so the Internet Computer traditionally, like I said, has had these two languages, Rust and Motoko. But the project that I've been working on and is now shepherded by Demergent Labs, this project is called Hazel. And Hazel allows you to write applications for the Internet Computer in TypeScript and in JavaScript. So that is what we will be using in this course. And here are the technologies that you will be learning based on their environments. For the web browser environment, you're going to want to learn, we will discuss HTML, CSS, and TypeScript. By the way, I basically use TypeScript and JavaScript synonymously. I highly recommend learning TypeScript, embracing TypeScript. Just assume that TypeScript is what you're going to learn, that is the language. Technically speaking, you can just use JavaScript on the front end, and on the back end, for the Internet Computer, you could use JavaScript for a lot of it, but I recommend just using TypeScript. It'll make it simpler for us if we just discuss things in TypeScript. So front end, HTML, CSS, TypeScript, you want to master those. On the back end, on the Internet Computer, TypeScript, that's what you want to master. And then to connect both of these, the glue code, we're going to use just the Internet Computer front end library that lets you call your canisters. So that'll be simple, but when we get a little bit more advanced, when we have more advanced data and we want more advanced operations, then we're going to learn something called GraphQL. And that is a query language that is beautiful to work with. And that's kind of the glue between the front end and back end. By the way, this course will be very opinionated. I'm going to have my opinions in it based on all the things, everything I've learned and everything that I recommend. So, embrace other people's opinions if you like. I have these opinions for a reason. I generally think they're correct. They could be wrong. I often change my opinions. But the core principles that I'll try to teach you generally stay stable. And I've chosen these technologies based on a core set of principles that have served me very well over the years. So please listen to me. Learn HTML, master it. Learn CSS, master it. If you're very interested in building beautiful graphical user interfaces, you really, really want to get good at CSS. Like, that's probably what you want to really focus on. HTML is relatively simple. TypeScript will be good for you, but if you want to just be like a designer person who still codes, CSS is really what you want. So yeah, that's the triad. That is the triumvirate. That's what you want to learn for the front end. Like I said, the back end, TypeScript, and GraphQL. So that is a quick overview of the front-end technologies that we are going to be discussing and the back-end technologies that we're going to be discussing. I'll just throw a few other things out there for you that we will need to discuss as well. One is called version control. We are going to use Git. That's what I recommend. That's what basically everyone uses. There are some other version control systems out there, but Git is the one that you want to focus on. And that's very similar to like Google Docs or Google Sheets. You can kind of go look and see all of the changes that have happened. Git lets you see an entire history of everything that has changed in your code, who changed it, and it lets you have different histories that can branch off of each other. So you can have a team of like 5 people, and you can each go off on your own, and you can very easily incorporate each other's changes. It might be confusing to you now, but you will wonder how you lived without it. That's called Git. Another thing that we will learn is something called NPM. That stands for Node Package Manager. And Node Package Manager is going to let you really tap into the world of open source. And it's going to let you just go and grab any open source library that already exists that you want to use. You'll just be able to grab that, very, very easily install it and get going. It also has a lot of nice tools for helping you to test and deploy, and it's just a beautiful thing to use. So NPM, Node Package Manager, Git, the version control system. There's one more major thing here. We'll learn DFX as well. DFX is an command line tool for the software development kit. Lets you interact with the internet computer. If I haven't missed anything though, those are the main technologies. So just keep in mind HTML, CSS, TypeScript, GraphQL, DFX, Git, NPM. Hopefully that's it. Might be a few missed, but generally speaking, that's what we're going to do. So, awesome. I think I'm going to cut it off there for now. We will get into coding in the next episode. Sorry, it is going to be rough as I figure out all the streaming and stuff, but as time goes on, we'll polish these up, get better recording equipment, better background, make you proud, watch and appreciate your time.